Hello, this video will be about hypothesis testing, testing a claim about a mean. This video is for my students now that we are transitioned to online learning, but if you find this video helpful, please continue to watch. The objective would be use a formal hypothesis test to test a claim about a population mean, mu. The notation that we're going to be using is N is for sample size, X bar is for the sample mean. Remember, we use Greek notation for the population parameters, S for sample standard deviation, and mu of X bar for the population mean. Just like everything else we've been using, the requirements must be a simple random sample, and for either or both the conditions are satisfied for a population is normally distributed, or n is greater than 30, is greater than 30. Keep this train going. All right. So test statistics, we're going to be using this formula. Now, my students already have access to a master spreadsheet. I'm going to be showing you guys which one to use. Again, you can use any table for p-values or for the critical values. If you're not a student of mine, you can use that, and basically any stats book should have a table for these or how to find them. But once you figure out the test statistic for whatever you're testing or whatever sample that you're testing. Okay, again, there are just some other requirements here. I'm not going to spend too much time on there, but you can pause the video and look at it if you like. Same thing here. They're just pointing out more properties about the student t distribution. Again, I've already talked about this during class, but if you like to read over this, you can pause the video and read. Okay, so the example, I have two examples for this video, and then I have another example when we're only given just the sample size and the test statistic, and we'll see if we'll need to fail to reject or reject the null. So that'll be coming up, but this is just the first example. So the first example is about adult sleep. The author obtained times of sleep, which is this list here at the bottom, for randomly selected adult subjects included in the National Health and Nutrition Examination Study, and those times, which are in hours, are listed below. Here are the unrounded statistics for the sample. N is equal to 12, X bar is equal to 6.8333 repeating-ish, and S is equal to 1.9924094 hours. A common recommendation is that adults should sleep between 7 hours and 9 hours each night. Use the p-value method with a 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours. Now, the key thing we want to look at here is that it says less than. Now, that tells us that our alternative is going to be mu is less than 7, which means that we want a left tail test. Sorry, using a crappy pen. And again, this is my alternative, and then we already know that our null has to be equal to 7. Okay, so these are going to be the two claims that we're going to be testing. Okay. All right, again, I'm just going over the requirement check that, yes, this is a sample that is a simple random sample, and the second requirement is that the population is normally distributed, or n is greater than 30. The sample size is n is equal to 12, which does not exceed 30, so we must determine whether the sample data appear to be normally distributed. Once we put it all in, we see that it does. So this is just a visual view of the data. Okay, so looking for the solution here, the claim is that the mean amount of adult sleep is less than 7 hours because mu is less than 7 for the alternative claim. So again, just kind of like what we already talked about, this part is my null, this is my alternative. We already talked about that on the previous slide. Okay, we're going to be working with a alpha, which is our significance level of 0.05. So I'm just going to pop out of here for a second and go to the master spreadsheet. Now again, you're going to want to use the T template one sample here. See if I can hang on. So we're going to want the T template one sample here at the bottom, and we're going to want to use this significance test for T sample, this guy right here, which is the second one on the sheet. Now I already have the values inputted. Again, I have my sample mean, which is X bar here. Then I have my hypothesized value, which is 7 here. My sample standard deviation, which is given in the problem here. N, which is 12, where remember degrees of freedom is going to be n minus 1, which is located here. And the significance level, which is told at the very end, is 0.05, which is located here. So remember, the red numbers are the ones that you have to input. The black will do everything else for you. So again, for the degrees of freedom, I already calculate, which is 11. Now our test statistic is going to be negative 0.289, and then in the homework, they're just going to ask you to round off to 3 significant values. Now remember, we're looking for a left tail test. So we're going to want this guy. Let's see if I can. There we go. Okay, so we're going to want a left tail test, which will give us 0.38868888846. Highlight that. And then so with our final decision, we know that, again, it does it for you. We're going to want the fail to reject here for the left tail test. Okay. Now, let's just pop back to the slides. Okay. Now, we get that with our test statistic here, which is what we already found. Again, this is just different visual representations of what it looks like. If you were to use a TI 83 or 84 plus or Excel. Again, with the significance value, this number, the p-value that we get, is greater than our significance level, so then we know that we need to fail to reject the null. Okay, which again is already given to us in Excel, so it'll do it for you. Okay, so our other example is that the mean body temperature is really 98.6 degrees Fahrenheit. So a data set that we have, which is in the appendix of the book, and again, the book that we're using is Essentials of, Elementary Statistics by Mario Trifola, which includes the measured body temperatures with these statistics for a 12 a.m. on day 2, where our N is 106, X bar is 98.2, S is 0.62, and they want us to use a 0.05 significance level to test their claim that that the common belief that the population mean is 98.6. Now, the language we want to look for is that they said the population mean is. So by saying that, well, let's get our null out the way. So we know the mean is going to be, our null is going to be 98.6, and because they say population mean is, well, we want the mean is not equal to, so this is going to be a two-tail. Oops. Okay, so let's go ahead and test that. Let's go to Excel. Erase all of this good stuff. Okay, so we want X bar. Alright, hold on. I think I forgot to make it back to the clicker. There we go. Okay. Alright, so this guy, our X bar is going to be 98.2. Our hypothesized mean is going to be, I think it's 98.6. I'm just going to pop back out of here really quick just to double check myself. Yeah, 98.6. Our sample deviation is going to be 0.62, and my N is 106. Now I'm going to keep the significance level. Alright, so instead of looking for the left tail, we're looking for a two-tail test. So we want this guy, which tells us that we need to reject the null. So following back through the slides, again, they're just talking about the requirements. You can pause if you want to look at that. Okay. So again, we already have the claims that we have. All right. So here we get our test statistic, which is what we get in the Excel. And so we know that we need to actually reject the null. All right. Now again, they're just talking about the p-value here. It is less than 0.05, so we would need to reject, and that is all. The next video I'll be making will be about testing a claim about a standard deviation or variance. For that other example problem I was talking about, I'm going to upload a separate video, and I'll try to include that in the link to this one, or just send it to you through the class. Okay, I hope this helps.